Good morning, everyone. Welcome to the first talk of Track 3 Black Hat. I'd like to introduce Dmitry, Chastuhin and Alexander Bolshev, who will be presenting With Big Data Comes Big Responsibility, Practical Exploiting of MDX Injections. Thanks.
Hello. Okay. Hi, my name is Dmitry. This is my colleague Alexander. We work in European scan company. Today we will tell you about OLAP and MDX technology and how an attacker can compromise the critical data using this technology. As I said, my name is Dmitry. I work in the field of information security and in particular business application security. What's more, I and my friends are the organizer of hardcore security conference in Russia, 0 Nights. You're welcome.
My name is Alexander. I'm a distributed system researcher. I hold PhD, works as auditor at ERP Scan, and I participate in the life of Russian DEFCON group. Okay, sorry. My name is Alexander. I works at ERP Scan, holds a PhD. I'm distributed system researcher, and I participate in the life of Russian DEFCON group 7820.
Okay, the company we work for is called ERP Scan. We are the developers of ERP Scan security monitoring suite for SAP, and we conduct a security assessment of business application, embedded system, and mobile systems. We find various vulnerabilities in them and get acknowledgements from vendors, blah, blah, blah. What we will speak about? First of all, of course, what is big data, OLAP technology, details about this technology, a few words about MDX, language, about attacks on the MDX, and we'll show some example, some demo, and conclusion, of course. Let's start.
Okay, let's start. Now let's talk about what is OLAP and what is big data. Online analytical processing OLAP is an approach to formulate and answer multidimensional queries to databases. And when I say large here, I mean really large datasets. OLAP technologies are developed by many software giants since the end of 20th century, and OLAP and business intelligence were initially developed to help top and middle level executives to analyze the information about processes and data inside and outside and around company. OLAP is all about business intelligence and big data. OLAP is based on online transactional processing, original and standard databases. While OLTP is about business processing and business strategy, OLAP provides managers with information that can be used for decision making and business analytics. Also, OLAP provides tools for data mining, for example, DMX language. After first appearing in the end of 20th century, the use of big data technologies gradually expanded to the several fields where analysis and decision making is based on large datasets. Now the most popular fields to use OLAP and big data are advertising, especially online advertising, healthcare, energy, government, and retail markets. On this slide you can see main players of OLAP industry. It's Microsoft with Microsoft Analysis Services, SAP with SAP NetWeaver BV, Oracle ESS-based and OLAP services, SAS OLAP server, IBM Cognos T1, open source icCube solution, and Pentaha Business Analytics. And there are much more solutions. Many of these services can be accessed directly from the web, and you can find them on Google using these docs. For example, with Google Docs, Google Doc, Pentaha Business Analytics, you can find many Pentaha user consoles with default passwords, without passwords at all, and others. And you intentionally can find some surprising big companies that are using OLAP, as you can see on the screen. So why they are all using OLAP? Imagine that you have a large data set about the supply of goods structured in a simple table, as shown on the slide. What if the company manager needs to get consolidated data totals about suppliers ranged by company, city, country, supplier? Cannot really be imagined in 2 dimensions, which is usually used in OLTP databases. What will happen if we also need the information requested above versus customers or trade routes? Okay, now we in 4 or more dimensions. Welcome to the OLAP and MDX world. Looks a bit crazy, yeah? Now the cube idea will help us. The data is presented as 3-dimensional or more n-dimensional structure. For example, this picture shows a cube which is created in accordance with data from the previous slides. It's actually 4-dimensional, but I'm sorry, I'm not very good at drawing hypercubes. Okay, let's now talk about language that allows us to make queries to such cubes. What is MDX, multidimensional extensions? OLAP stands far from OLTP, so using OLTP languages such as SQL isn't convenient for accessing big data. So MDX was created to replace SQL in this area. You might remember that SQL was not originally intended for programmers. MDX too was not created for programmers, but rather for managers and analysts. Ironically, in the course of time, MDX became even more complex than SQL. At a first look, MDX appears to be similar to SQL, but it's wrong opinion. There are at least two main differences between them. MDX is much stricter than SQL, much inconvenient to attacker, and usually you can't modify data with MDX. I've said usually because in some cases you can, but we will talk about it a bit later. This slide shows a standard layout of select query in MDX. Like in SQL, select is used in MDX to retrieve a sample of data. The select is the main object of MDX language. It does look slightly like SQL, doesn't it? The query starts with the with section, which can define measures, objects, and members to be used in the rest of the query. After that, the select section defines which dimensions of the cube will be used in the resulting sample. And finally, the from sections defines which cube or subcube, if it's created by subquery, the data is to be retrieved from. It also defines filters and slicers. You can see a sample MDX query on this slide. This query will extract information about the paid salary, which is described in the first dimension on columns, against male employers from the marketing department, which is described by the second dimension on rows. Here a new measure was defined in the with section of the query. In practice, measures can be more complex and even include subqueries in some cases. You can also use on 1, on 2, on 3 without dimensions. The data is queried from the cube called HR, and the widest filter is selected, all members of the store. Okay, now we've written a simple query. How it will be processed in big data system. As was mentioned earlier, in the most common case, OLAP is based on OLTP. When you write an MDX query and send it to OLAP server, it's picked up by MDX analyzer or interpreter. It converts the MDX query into MDX-XML query. We will talk about this XML for analysis a bit later. And send it to OLTP. OLTP can process the query directly or convert it to the set of SQL or some other, for example, NoSQL queries. The resulting data is gathered and sent back to the application. Many OLAP service works in the way is depicted on the slide. Now we know enough to plan how we can attack MDX. Imagine that we have a vulnerable application that fails to filter user input and processes it directly into some parts of MDX query. What are the vectors we have? We can attack MDX-XML with good old XXE injections and other fun XML attacks. We can use pure MDX injections to gather or even modify sensitive data that was not supposed to be accessible by vulnerable application. Also, we can use MDX extensions, user-defined functions to expand the attack and even get remote code execution and other funny and evil stuff on the vulnerable system. Okay, now let's talk about how to inject. What features will help us in MDX injections? In MDX, like in SQL, there are two types of commentaries: single line -- space -- and multi-line ****/. Also, we can use subqueries to create subcubes in the from part of the query so we can expand our attack. There are several built-in functions that work in many dialects of MDX, and with these functions we can crawl dimensions and re-engineer the cube structure. These functions may be parent, default member, first child, last child, and others. MDX injections are a bit different than SQL. In SQL, we in most cases inject into the select and where part of the query. In MDX, due to language specifics, the application can insert user input into 3 different parts of the query, in most common cases, of course, as shown on the slide: into the members definition, into the dimension specification, and into the where filter or slicer. So we have 3 possible types of MDX injections with possible results. if we are able to inject into pre-select section, we can do almost everything, with the exception of data modification. If we can inject into the select section, we can gain partial information about cube metadata and gain access to unexpected and confidential data. And we can also access other cubes, of course. In the where section, you can only use blind MDX injections, and we will show you how. And of course, you can call user-defined functions in any of these sections. Here is an example of simple MDX injection into the first section, pre-select section. The injection code is highlighted with red color, and commented the rest of the query with green color. Here we inject the code that will return almost all members of cube hierarchy. We are using special built-in keywords of MDX such as dimension count, unique name, current member, and members, which will allow us to access cube hierarchy metadata. Another example describes the situation where we can only inject into dimension specification of the select section. As you remember, in the original query, the application specified, for example, with combo box, it can be displayed on the combo box, the gender of an employer. We can inject into the query through the value of this hypothetical combo box, and we can slightly modify the query so it will return not only the employer's salary, but also system usernames or possibly passwords, if it remains in the cube, of course. This is not a rare case. Often the cubes are created semi-automatically based on OLTP datasets, so passwords will remain in OLAP data too. Let's talk a bit some cool features of MDX that will help us in process of injecting queries. First, as in many SQL dialects, you can start a multi-line commentary with slash and asterisk, and you don't need to end it with asterisk slash. Also, you can use dimensions keyword to access cube dimensions, and lookup cube keyword provides you to access to another cube. The descendants keywords help you to get all data about and around the member. And if you need to pass data between queries and subqueries through a different part of the query, you can use strings to string functions such as set to str or str to set, and others to convert members and objects to string and from strings. Also, there are blind MDX injections, and we will show you a simple technique. On this slide, you can see the query that will return null when there is no login with this starting substring, and something when it exists. You can use instr MDX function to speed up the process, and if you re-engineer the cube structure with blind injections, you can use less and greater operators to speed up the process. Funny thing, in Microsoft Analysis Services, this is a correct MDX query. Yes, it's correct and can be run from a user with least privileges. So if you control pre-select or the beginning of select part of the query, you'll probably be able to retrieve all cube data and structure. That can also be possible in several cases when you inject in ASP.NET applications if they don't use LinQ and using raw MDX. Microsoft always puts us in the position of this cat with such features. So when you write application for Microsoft Analysis Services, double check the input data if you are using plain MDX queries. And a couple slides about data modification. MDX isn't a SQL, and normally you can modify data with MDX. MDX statements like alter, create, and drop are designed for creating, deleting, and altering temporary meshes and sets, not for changing cube data. But in rare cases, you can modify data with update statement. Here is simple update query, where sales amount at the Europe region is modified to 20. The worst thing in update is that it can be subquery or can start with statement. So you can inject data modification statements only if two conditions is true. You control all query and data modification is enabled for your user. Now Dmitry will tell you some more cool things.
Okay. Let's talk about another feature of MDX query language is user-defined functions. User-defined functions, or UDF, is a function written by the user or third-party developer which can take and return values in the MDX syntaxes. So a developer can use them to enhance the function of the language and the application which uses it. To call a UDF or user-defined function, this kind of construct must be used in a query. First of all, it's program ID, after that exclamation mark, after that function name, and his arguments. We will now discuss some attacks on OLAP servers where user-defined functions are used. icCube OLAP server will be the object of these attacks. Why? First of all, it's a quite popular solution for OLAP servers. Second, it has a free community edition, and finally, this solution is a cross-platform because it's written on Java. The developers claim it to be fast, reliable, and secure. Another advantage of this software is that it's shipped with a lot of utilities for developing and debugging queries, creating web reports, and so on. So sum up, the availability of this solution is why we have chosen it. This is how work with an OLAP server looks for the end user. Fancy HTML5 diagrams and checkboxes, pretty cool interface, allow working with the multidimensional data conveniently and generating queries very easily. And this is how the client working with OLAP look for anyone who looks into a sniffer. Of course, MDX is appropriate language to be used in queries, but it's not the surprising part. Can you see the MDX parameter in the post request? It contains the whole MDX query. It means the attacker need not bother with searching for injection parameters and bypassing filters. They just need to understand which cubes, measures, members are there and compose the correct query. However, we are interested in user-defined functions right now, so we turn to them. So, an icCube is Java application. Well, then maybe Java function will serve as user-defined. Let's try to call math.py using the common entry format. J as program ID, after the exclamation mark, and math.py. You can see the full entry on this slide as well as the result. The server has successfully replied with the value of pi. Rejoice looks like we can call public static Java function. Let's try the obvious get property method. And here is the part where we got our first fail. We got an unknown method error. And we tried a couple more cheesy functions and concluded that the developer had restrict access for MDX to all dangerous methods and functions and left to us just boring classes like a math. However, official documentation contains a subtle hint that much more than math is possible if you add the desired classes to the server directory called lib. It was only logical to have a look at the jar files which we already contained in the directory and decompile them and find something interesting. And we find it. For example, jar file commands io1.4 contained a method read file to string, which allow us read any file from the OLAP server. Okay, let's try to read a file called 111.txt, which contains text hello MDX. The text has to be displayed somewhere, so we will cause a wrong dimension name error, and that's how we can read the content from file. This slide shows the final file read query is a select statement where we call user-defined function read file to string. And this slide shows the result of our works. You can see that the server returned an error. Hello MDX is neither a dimension not in hierarchy within the cube. We got an error which contains the file content. But we don't, okay, we can read the file from server, but we don't manage to read anything interesting from the server because special chassis, commas, and even space crash the MDX parser and only part of the file was transferred from the server. For example, if we try to read the file hello MDX white space blah blah blah, we will get error unexpected statement. And the solution is obvious. Just encode the file content, for example, with base64. By the way, we found a method encode base64 and add this method to the query, send it, and here's the file again. We got the error, syntax error, unexpected statement, AQ. The base 64 string probably contains an AQ sequence, which means equivalent in MDX. Okay, encode file content twice, and got the error again. The parser returned an error about a missed expression after the equal operator calls the symbol. The equal symbol is frequent in the end of base 64 strings. To resolve this problem, just concatenate the base 64 strings which contains equal symbols with one letter, and then expression will be correct. When MDX parser works, it drops equal symbols and all symbols after that. But we know the equal symbol is always at the end of base 64 string, so we can still decode it. This is our final user-defined function call, which allows us to read any file from the OLAP server with any symbols. We call user-defined function read file to byte array. After that, decode it twice by the encode base 64, and after that concatenate with one charset. And our example is S. The server return replies with an error which contains a base 64 string. We must not forget to add an equal sign at the end, and after that we can decode the string several times and get the content of the file 111.txt from the OLAP server. This vulnerability is very interesting, especially because user passwords in icCube OLAP server are stored as base 64 encoded string in configuration file icCube users. It is year 2013, and applications still store password in plain text. It's abnormal. And just before Black Hat, icCube shut down those methods, but the mechanism of calling those functions is flawed by nature and can be successfully exploited with the help of other critical methods. For example, we can try to retrieve the user home directory where the official icCube demo server is launched from. We will use for that method encode string and get string properties from crazydev jar file, which still work. And again, we got the same error with base 64 string, and after decoding it, we get the necessary information about user home directory /home/demo3. Now I'll show you a small demo. Oops. Here is a web interface of icCube server. We're logging in as demo users, and our goal in this demo is read a file config with stored passwords, and after that log in as administrator. Okay, now we're typing I don't know. Now we're typing a simple request which return an error about wrong name of dimension, and now there's a user-defined function which return a user home directory path. Send request, and we got error with base 64 string. Now we decode them. and we get normal plain text. We need this path because icCube store config file in user directory. Now we know this path and we can send a request to read the file with passwords. Oops. I forgot double quote. Send the request and we got again error with base64 string. Decode the string. Decode the string several times. And finally, we get a configuration file with usernames, passwords, role names. After that, decode the passwords, and we can successfully log in as administrator. And now with administrator we can manage users, create cubes, and configure the server. And back to the other presentation. Okay. But this is not the end of the adventure of user-defined functions. Current dangerous methods is only half of the problem. The other half is the method which contains certain vulnerabilities themselves. An example, there is a method called free space windows which return information about the hard drive space occupied by a certain directory. But look how it's implemented. Yeah. Our comment injection is self-invited here because the path parameter is not checked in any way by the writer, just concatenate to the dir command. The code of calling calculator, for example, is quite simple and elegant. Just call free space method and point calc exec. Let me show how it works. Again, we have an interface, national interface for the server logging as daemon users, and make a request. Yes, it's there we have a process list from the server, and now we send the request and got a calculator on the server. Very easy. You don't need any buffer overflows or something like that. Just call user-defined function. There is, if you can see. code successfully execute. Back to our presentation. And
okay. Now it's more words about UDFs. Let's return to Microsoft, which we love more than icCube. It's more secure. And you can guess you can also use user-defined functions in Microsoft Analysis Services. In the older versions of it, pre-SQL Server 2005 Service Pack 1, you can use library keyword to load type libraries, ActiveX controls, and even executable files to load libraries with user-defined functions. Thanks God, this functionality was removed in SQL Server 2005. But in modern versions of SQL Server, you can still extend MDX functionality, but now with third-party .NET libraries. After adding a library to an MDX project on this SQL Server, you can directly access them in MDX queries. For example, one of the most popular MDX extensions is Analysis Services Stored Procedure Project, ISSP, which vastly extends MDX functionality. For example, it provides an SQL query library that can be used in MDX for direct SQL injections with permissions of MDX users. Lazy developers don't want to write their own extensions or learn MDX. They just use SQL query extensions, as you can see according to the Google results. SQL Server provides some functionality and security system for third-party libs to prevent unauthorized access and force them to run with least privileges. Great job, Microsoft really, but who uses it and who creates multiple user for MDX applications? Most of developers are still too lazy, very lazy. So if we can inject in where part of the query, as you can see on the slide, and the SQL query extension is installed, as is often case, we can do really evil things, such as, for example, drop some tables or call some SQL functions, maybe exploit MD shell. There are also some third-party extensions libraries that provide similar functionality. For example, for SAS OLAP server, PWS SAS help query will do the same thing. And they also seems to be actively used in the wild. And now Dmitry part again.
And I would like to leave MDX alone for a while and introduce you to XML for analysis. XML for analysis, also called MDXML, is a standard which describes the capabilities of transferring MDX requests into XML messages. XMLA is based on XML, SOAP, and HTTP. XMLA was developed to be as simple as it possible, so it only contains two SOAP methods, execute and discover. In accordance with the name, the discover method is necessary to discover which entities are present in the cube, what they are called, and how large they are. Within this method, the user may specify which entity of the OLAP server he wishes to know better. This is how typical discover query looks. The query includes the directory name, the format, and so on. This method can be most useful to know the names of existing cubes and determine the most interesting dimensions and methods in them. This screenshot shows the query to retrieve the names of the cubes presented in SAP ERP systems. You can see that the replies include the cube's name as well as information about the owner, update date, and description, and so on. The second method, execute, is more interesting. It has two parameters: a command to specify the MDX command to OLAP server, and properties to, of course, specify the properties like directory names, timeouts, and others. The slide shows an example of SOAP request execute, contains a request to meshes which are present in OLAP server 2 called cells. Back to the attack now. XML for analysis is still good old XML, and all classic attacks are applicable for XMLA. For example, tag injection, XML external entity, XML bomb, XLST code injections. Let's study one of them using the example of the OLAP server and the XML service of the SAP ERP system. Upon sending, if you send a request to by the CPI to SAP, we resolve WSDL contains the description of method discovery and execute. Let's try a classic one XML attack called XML external entity or XXE. We will try to read file from the SAP operating system. hard drive, we inject foo as request entity and hope to get an error containing the context file of the file called passwords.txt. And indeed it happens, the file is successfully read and inserted into the request. Then the parse crashes, which with an error returns the result of its work, including the text of the file. This vulnerability can be used to read file, conduct denial of service attacks, as well as server-side request, forgery attack, and so on. Another example of this attack on the OLAP server through XML and MDX, we show them on the other popular OLAP server called Pentaho. Pentaho OLAP server also open source solution. We found a lot of Pentaho OLAP services in the internet, so any can use Google Doc, which we showed on previous slides, to find this OLAP server. Pentaho transfers the request into the cube as XML into JSON and calls this technique MQL. That's how Pentaho looks for the end users. Again, HTML5 interface with when user can easily create a request. And this slide shows how looks request to OLAP server in Sniffer. In query parameter specifies the MQL request, which contain XML, and again we found XXE there. Let's show the attack. Attacker wants to read file 1.txt from the OLAP server. He specifies a request an external document type XML, which is located on their web server. In our example, it's 1.xml. This doctype file contains the two external entities, one which points to the file from the OLAP server, 1.txt, and another one which points to the attacker server and contains information from the first entity as request payload. After that, attacker sends MQL request with external doctype to the OLAP server. When the server parse request, he read MQL, find XML, find external doctype, find first entity, read file 1.txt, find second entity, and after that make the request which contain information from the file to the attacker server. As a result, attacker got file 1.txt content. And again, Pentaho OLAP server have a little feature here. He has a lot, and he was logging database users and password into log file. You can just read log file and get
base 64, as always.
Yeah, base 64, it's secure. And in the end, I would like to mention other classic attacks which are also possible thanks to lack of data filtration in MDX. MDX is frequently used in various web reports, so potential attacker can use an MDX query to transport, for example, JavaScript payload or maybe SQL payload. It is possible because a lot of developers forget to filter data in MDX, or maybe they just don't want to. A good example is a popular OLAP server called Panorama, which once served as the basis for the similar product by Microsoft. There is a typical query for taking a data sample out of cube in Panorama OLAP server. There is not true select statement, but if you look closely, there are sections in the query which is responsible for dimensions, rows and columns. It means that an attacker can try to inject MDX operators in the sections too. You can also see on this slide that the attacker can easily use JavaScript code in place of cube names or member names. The code will successfully pass the filter and will be executed in the current domain context. Thus, MDX is the battlefield for most known attacks and especially for web-relevant attacks. And conclusion, blah, blah, blah. To sum up, MDX is a very popular language in business intelligence and is the main query language which is used to retrieving data from InfoCubes and OLAP servers as whole. It does not have decent alternative now, MDX resembles SQL a lot, but there are a lot of difference both in semantics and in syntaxes. Moreover, the developers of business intelligence applications have forgotten about security from some reasons. They send along all data sample queries without any filtering. Vulnerabilities and error in MDX query processing can lead to dire consequences like data stealing, file reading, privilege escalation, remote code execution, various SQL and JavaScript code injection, etc. And the last slide. If you have a question, we will answer for this now.
Thank you for your listening our bad language.
Yeah.
So, all the attacks we described, can they all be substituted by just configuring the servers correctly? Or is there anything that's like right out of the no matter what you do? Basically, you set up a security OLAP.
If you are using Microsoft analysis services or SAS analysis services, you can config the server correctly and all attacks will be mitigated. If you are using Pentaho or icCube, the vendors still need to patch some vulnerabilities and crazy features, as I think. Such as base 64, as I've said earlier. Okay?
How many of these interfaces are generally within the enterprise, like these big data analysis tools that might have managing big user of these, right? So how many are within the enterprises versus how many of these interfaces are generally exposed?
As I understand, you asked about how many interfaces exposed to the web and the internet. Yes?
Direct on the internet, so I guess like it could be internal quality interfaces, internal part of the
I understand. Yes, Pentaho Business Analytics has many exposed web servers to the on the internet that you can find with docs. As to analysis services, there are few, and you can find some icCubes on Shutdown. But if you're working inside enterprise company, you will find them as insider. The web interfaces are exposed, and sometimes you can execute any MDX query. So if they're using some cool MDX server or using some third-party libs as SQL query in Microsoft Analysis Server, this will have bad consequences for the company. Okay?
Are there open source tools to exploit the vulnerabilities using an MDX to exploit some of these attacks? Are there open source tools or something marketing tools?
Can you be a bit louder, please?
Or use Microsoft.
I just want to know if there are any open source alternatives to ERP scan. The attacks you described, can we use some other open source alternatives to attack Pentaho or MS?
We don't use any closed source tools to attack them. We use Burp Suite, that's open source. You can use it too. Only just Burp Suite and Notepad, nothing else. You need to attack MDX.
What if it was automated attack, like let's say ZAP or any one of these tools that are open source, WPA that are open source, then they have payloads for process scripting and SQL injection. Do they have payloads for MDX injection as well?
Sorry.
Maybe you can answer on your question a little bit later
Yeah, sure.
in color.
Any other questions?
Yes. Any of scanning tools you guys can provide for Java scanning to check the index?
Maybe in near future we will add functionality to ERP scan to scan it for MDX injections and more. It will be a month, 2 or 3 months maybe, I think.
No question. Thank you very much.
Okay, thank you very much again. Thank you.